Hi
Yeah,
everyone, welcome to our session deep dive on Shadow DOM and CSS in Lightning Web Components. So today Alba and I are going to be the presenters, and thank you for joining us because I know for most developers CSS is not the most interesting topic, and it might be even unimportant for some people. But frankly, without knowing the core concepts of CSS, if you style your components incorrectly, and then there some issue comes out, you'll have a nightmare fixing those issues. So today Alba and I are going to just scratch the surface of CSS basics and hopefully leave you a bit confused so that you go back, do a lot of trial and error, and really find out how things work. So my name is Aditya and I'm a lead developer advocate at Salesforce. You can follow me on Twitter at my Twitter handle specified on the slide and below my video. You can also reach out to me on email in case you have any questions. So my colleague Alba is also with me today. So Alba,
yeah. So, hi everyone. Thank you so much for joining. My name is Alba, and I'm also a developer advocate. And you can reach me on Twitter, and also if you have any questions on my email. This is a forward-looking statement slide, our favorite slide, which just means that Salesforce is a publicly traded company and you should make purchasing decisions based on the functionality that is generally available. But almost everything that we are going to see today is GA still except a tiny thing which is styling hooks, and I think styling hooks are going to become GA very soon. So no worries at all. So this is our agenda. First of all, we are going to get into the details of Shadow DOM. Shadow DOM is one of the standards that Lightning Web Components embraces, and we're going to see the different implementations that we have in Lightning Web Components and Lightning Web Components OSS. Then Aditya is going to explain some topics, some CSS topics that are important to understand in regards to Shadow DOM and how CSS behaves in Shadow DOM. We're going to talk about the different ways in which you can load CSS styles into your components and their implications on how these styles are going to be scoped in the end. And finally, we're going to talk about CSS Custom Properties and how we're using internally in Salesforce to implement some of the features that you can use as of today. So first of all, let's start talking about Shadow DOM. Shadow DOM is one of the standards that conforms the web components general specification, right? And Shadow DOM, I think the best thing to understand what it is with an example. So imagine that you have this regular DOM, right, in your web page. It can be built by Lightning Web Components, but it can be a generic web page, and that you want to add some elements that hang from this div element that I have highlighted in red here, right? So one option would be to just add the elements in the regular way that you are used to, add them to the regular DOM. But a different option that is going to provide us some benefits is to create a subtree that it's encapsulated. This is a shadow DOM tree. Normally, when we create a shadow DOM tree, what happens is that a shadow boundary is created around the elements that are part of that shadow DOM tree, and that is going to provide some encapsulation benefits. There are some names that you should know when talking about shadow DOM. So normally, the element to which we attach the shadow DOM tree, we call it the shadow host. And we also say that the first element of the shadow DOM tree from which the rest of the elements are going to hang is the shadow root, right? And this is something that you are going to be able to see in Chrome Developer Tools, for instance, when you inspect elements that have a shadow DOM tree attached. Normally, in this case, when we start using Shadow DOM somehow, right, we have also some terminology to differentiate the regular DOM, which we normally call light DOM in this context, from the Shadow DOM. We can create one or more shadow DOM trees, right? And all of them are going to uh, add some subtrees to our light DOM, encapsulating some of the elements that we want to encapsulate for some reason. We are going to see that a web component normally follows this approach. At the end, when your DOM is rendered, the final result is going to be exactly the same as if you added the elements in the regular DOM in the regular way, right? But that's going to be at the end. But we're going to see that this provides some encapsulation benefits that you are going to like and want to have in your applications. So how do I attach a shadow DOM tree? How do I create a shadow DOM tree? There is an API for doing that, right? The API is attach shadow. You have to decide if you want the mode to be opened or closed. We are going to see that the difference in a second. And then once you have attached a shadow to an arbitrary element, in this hypothetical use case is our div, but it could be any element in your DOM tree, and then you can start adding elements to the internals of that shadow DOM tree. We are going to see that once you attach a shadow, the element is going to have a property called shadow root that you can it is the one that becomes like the main element for your shadow DOM tree, and you can query that property and so on, right? So I've mentioned encapsulation benefits. Which encapsulation benefits are we going to get when we create a shadow DOM tree? First, the markup is going to be encapsulated. Why? Because the elements that belong to a shadow DOM tree are not going to be queryable through the regular way, like doing element or document dot query select or whatever. They need to be queried through the shadow root property that exposes the internal element of the component. Remember that I told you that you have to select between open and close shadow. This property is going to be available only in open mode. And that's the only difference between open and closed, right?
So
Second,
really, Alba,
yeah,
that means if when creating the shadow root, I specify that I should create it in the closed mode. Essentially, I'm preventing anybody from even querying the components in my DOM.
yeah,
So
exactly. So
automatic.
imagine that you have some arbitrary JavaScript in your page, and that arbitrary JavaScript is doing like a document dot query selector whatever. That's not going to interfere with your DOM at all because your elements are enclosed in this shadow root property and are more encapsulated, right?
Okay.
Then, in the second way that we're going to encapsulate them is regarding the behavior. Why? Because the events that you fire from the inner elements of your component are not going to escape the shadow boundary, this boundary that we defined here, unless you want them to do so. That's something that you can control as a developer. You can do that. You can mark an event as something that you want to escape the boundary by setting it as bubbles and composed, but that's not the default when you create a custom event. One thing to know here is that all the user agent dispatched events as click, touch, mouse over, etc., those are going to be composed by default. So those escape the shadow boundary by default. And third, Aditya, There is another way in which we are going to encapsulate the component, which is CSS. But here we are going to maintain 1 second the question. We are going to respond this question later, and Aditya is the one who's going to tell you about this in a second. Okay?
Yes, this is why we are in this session, by the way.
Exactly. Great. So until now, I have talked about Shadow DOM in general, right? But I mentioned that Shadow DOM is a standard that is part of the Web Components specification, right? And it is part of the Web Components specification because the standard says that when you create a web component, you have to attach a Shadow DOM tree so that your web component is encapsulated, right? So if you want to create a regular vanilla web component, I'm not talking about Lightning web components yet, this is the way in which the standards say that you have to do it. You have to create a custom element that is going to extend the standard HTML element interface, and then you are going to attach a shadow in the constructor. That way, we're going to encapsulate the internals of the element in the 3 ways that we have seen before. If in a later moment you need to query the elements that are internal to that shadow root that you have created, you can use the shadow root property, which is going to be exposed for you as we are using the open mode here. If you take a look at a native web component in Chrome Developer Tools and you activate an option on the settings, you have to activate an option, I think it's called User Agent Shadow DOM. You are going to see something like this. This is the flattened DOM is going to be exactly the same, but there is something in Chrome Developer Tools that tells you that those elements belong to a Shadow DOM tree, right? So what about Lightning Web Components? For Lightning Web Components, we make it easier because instead of extending HTML element, you extend Lightning element. And that means that this is a class that we have created that extends HTML element at the end, by the way, in which we have added some functionality. So that functionality is going to make it easier to create web components because we don't have to attach a shadow DOM tree, etc., and a couple more features that we have implemented there. But under the scenes, when you create a Lightning Web component, you are going to create, you are attaching a shadow DOM tree to that web component, Lightning Web component that you are creating. That means that the elements of the Lightning Web component are not going to be accessible in the regular way. You cannot query them with document.querySelect or whatever. You have to use the template property. It's the same as the shadow root property here, but we had to change the name, and you are going to see why in a second, because on the platform we use a synthetic shadow for now, right? If you inspect a Lightning Web Components that has been created with Lightning Web Components OSS, then you are going to see something like this. You are going to see that this is a native, that the component is using a shadow DOM tree. But if you inspect a component, a Lightning Web component that is running on the platform, you are not going to see this. You are going to see something more similar to this. You are going to have the component and then an attribute that is trying to mimic the native shadow DOM implementation. Why do we do that? This is important. We do this because Lightning Experience supports a wide variety of browsers, including some old browsers that don't support native Shadow DOM. And we wanted to support all those browsers. So that's the reason we decided to create a synthetic implementation of Shadow DOM for when your Lightning Web Components run on the platform. That is important, right? By the way, this is something that you can activate in Lightning Web Components OSS if needed. and it's easy to do, right? So let me show you this in a demo for a second. Sorry. Okay, this way, better. Okay, so here Aditya and myself have created two applications to explain the examples in this talk. One of the applications is running on the platform, and the other application is running outside of the platform. So here I inspected the elements that belong to this Lightning Web component here. This is a Lightning Web component that is running outside of the platform, and by default, Lightning Web components outside of the platform uses the native Shadow DOM implementation. That's why we are seeing here the shadow root property. But if I go to the platform component, right, here we have another component, which is the one that Aditya is going to explain in a second. And in this component, we can see these attributes that I showed to you in the slide. Why? Because we are using a synthetic implementation, right? So
Okay. So, Alba, can you also show how did we enable synthetic shadow on LWC OSS?
yes, of course. So if I come here, this is my Lightning Web Components OSS application, which is using the native shadow at the moment. But if I go to the code of my application, hopefully you can see this.
And you
And
can make it a little bit bigger.
like this.
Yeah, this is
Okay.
good.
Okay, so what you have to do to enable the synthetic shadow outside of the platform is to import this module at the top of your index.js file. Simply that. So let me show you what happens when I save. I have saved the file as I am running the watch mode. This should be reflected into my app. And yeah, so here I have activated the synthetic shadow, right? The look and feel has changed a bit. This is because Lightning Design System styles are being applied while using the synthetic shadow. And Aditya is going to explain why in a second as well. So let's continue with
Now,
our.
the reason I asked you, Alba, to enable synthetic shadow DOM is for the interest of our audience. So, as you've seen, she's written the import statement in the first line of index.js. It's very important that it is in the first line because if you put it in the second or third line, it doesn't work. And I have wasted a lot of time figuring out that. So please put it in the first line of index.js if you need synthetic shadow.
Exactly. So it happened the same to me. And I was with Aditya, like debugging the application and saying, how can it be? And finally, it was just simply that. Okay, so now I'm going to switch to Aditya's screen. Aditya, I think. Okay, perfect. And
Okay,
he's going to respond this amazing question.
so you've seen Alba has done an amazing presentation on how Shadow DOM works, but we didn't touch the core concept that is CSS. As you've seen very briefly, the moment she enabled synthetic shadow on LWC OSs, the styles seem to change, and you're going to know why. Basically, with CSS and Shadow DOM, one statement I'm sure all of you would have heard is styles defined in your parent don't leak into the child. So you ask anybody about Shadow DOM, they say all your styles are encapsulated, which means your parent styles do not affect your child styles. But is it really true? Is something that we are going to see in a demo. So what we have here is the org that Alba was showing you, and here is the code behind it. And we are going to look at two principles in order to understand how CSS behaves, and then you yourself are going to understand why things are behaving a certain way. So the two concepts that you need to know is cascading and inheritance. And the full form of CSS really is Cascade Style Sheets. So cascading is in the word CSS. So what does it really mean? So to know about that, let's look at this example. So here it's a simple web component which I called as cascading parent and its CSS file. So what I have here is a simple div, and inside the div is some text. Now the styles related to this component are in this file. And how does the browser know what styles to apply to this? So cascading is how a browser applies styles to a component. And the principle behind cascading is that cascading essentially combines all the styles that are applicable to a given element. So in the case of this div, what are all the styles that are applicable? So these are the two styles because both have the div selector. And what the browser does is it combines both of these styles and then applies it to the component. Now, when combining two styles, as you see, there is a property and there might be conflicts, which means two style selectors have given the same property. For example, here I've defined the background to be green, and in this selector I've defined the background to be some other color, which is bluish. So how does the browser know in case of this conflict as to which color it has to apply? For that, it applies some rules, and that rules is based on the concept called as selectivity. So selectivity, which basically says how selective is your selector. Actually, my bad, it is called specificity. So it's based on the concept called specificity, and it really is how specific is your selector CSS. So in this case, it is the div, and you can have different kinds of selectors in CSS. So there are three kinds. One is the ID selector, one is the class selector, and one is the type selector. So type is basically any HTML element. So in this case, div is a type. So you use the type selector here. And what VS Code shows you is how specificity is calculated. So the moment I hover over this style, it shows me what is the specificity of the selector. In this case, it is 001, where the first number stands for the ID selector, second is the class selector, and third is the type selector. And the ID selector is the most specific, whereas the type selector is the least specific. Now, the conflict resolution happens by looking at specificity. The selector that has the highest specificity wins. But in this case, the specificity of both these selectors is the same. So it is 001, and here also it is 001. So in the case where specificity is the same, the browser is going to use the one that appears last. So this is the one that appears last, which is why, as you can see, the blue color is applied to this div. Now, how do I make sure it applies green? Now, one common mistake that 99% of developers make is they use important. And using important is really a bad practice. You're not supposed to use important because it may help you in the short run, but during debugging and during the long run, it's not recommended. And the only place where you have to use important in your own styles is in case you're overriding a style from a third party CSS. So let's say you are using Bootstrap or something, and then there is a style that's getting applied on your component, but you want to override that. In that case, important is helpful. But if it's your own component and you're putting important on some styles that you yourself have written, that's a bad practice. So how do you increase the specificity of a given selector? So all you need to make sure is you move to these higher numbers. Of course, the ID selector is out of scope for Lightning Web Components because, as you know, you're not supposed to use IDs in web components because it is replaced during runtime. So the only option you have is to use a class selector, or you can increase the number for the type selector itself. So how do you do that? So here div is specific. I mean, the specificity is general. So it applies to any div element. Now I can increase its specificity by putting something else before it. So let's say lightning card div. which means any div that comes under the lightning card tag, it has to apply this style. Now, if you hover over this and see, the selector specificity is now 002, which means this selector is more specific when compared to this selector, which is when it's going to apply green. So that is how you have to write your styles. Please don't use important a lot. Now, like I mentioned, your CSS is going to combine all the different styles. So background of blue has taken preference. And of course, the padding 1 rem has also been applied to your style.
I have a question, Aditya. So do you have
Yeah.
to configure something in Visual Studio Code to get that specificity calculation?
No, it comes to you with
It
VS
comes
Code
by
by default.
default. Okay, that's great to know.
It's not even Salesforce extension pack, it's VS Code feature. So
Perfect.
use it as much as possible. Okay, so that was the first example. Now, when it comes to the second example, you will be able to know the answer now because here it is the same div, but I have defined a class of some color. It's the same text. And in my CSS, some color has a different background color. And as you can see, it's that color that got applied. So it is not in the order of what appears last because the selector dot some color is a class selector which is more specific. So the more specific styles are going to take precedence, which is why pink has come out. So that is the concept behind cascading. Now let's look at the third case. Here it's a child web component. So what I have in the child web component is again very simple. So I have a simple div again, and it has some text. And if you look at the styles of that div in the child component, you can see I've given it a background color of yellow. So as you would expect, nothing much fancy here. Whatever is the child component, it has come out. It's a simple div with the yellow background. But what you have noticed here, the difference between these two divs and this div is that it doesn't have a padding. So in spite of me giving a padding to the div in the parent component, the child component's padding is not affected. Now, that is because of Shadow DOM. That is the encapsulation that Shadow DOM provides. So if you've defined padding of 20 rem also for your parent components, your child component still shows the way it is supposed to. And here, notice that in case 3, the C child, that is the child component, is a child of lightning card. And you might argue that, okay, I have given the padding for a div element, but then this is a child of lightning card, so maybe it didn't apply. So I've put that use case also. So I've created a div inside which it is some text just like case 1, inside which I've put my child. So what happens here? Here at least you would expect that because this div is given a padding of 1 rem, you will think all the divs under this, including the child element, would be affected. But because of Shadow DOM, you can see the padding is not applied for the child elements div. So that is how cascading works when Shadow DOM is used. Now, at which point you might think, okay, you've understood how cascading works. I'm going to confuse you a little bit, and I want to take you to the second example, which is to show how inheritance works. So here I have another component. It looks almost the same, except that what I've done this time is instead of just some random text, I've defined sum in a line, and then I've given a span for text, and I've given another span for in parent. And what I've done is, apart from the previous styles of background, I've also given an additional color property to all of my style classes. So here what happens in the div, you can see that the div is styled as usual in the blue color, just like the previous example. And the text is colored in red. So sum is styled in red color because it is a child of div, and the div is styled in red color. And then the span class of new color is styled in green because I've defined the color as green for the new color class. And of course, by now you understand that this is more selective, so green has applied. Now for the span tag itself, if you see, I have not defined any style, but still the output shows it in red color. So why is that? Ideally, you would expect, because I have styled only the div and not the span, this should be shown in black is a typical expectation. But the reason span also is shown in red is because the color property is inherited from the parent. So since div is being defined with the color of red, span has taken the color of the parent element. And that is called inheritance. And one very important thing to note is not all properties can inherit colors or inherit features from the parent. How do you know that? Again, VS Code feature, hover over a particular element and then click on MDN reference. And you will be taken to the developer.mozilla.org where you'll find all the information about that particular property. And what it also shows you is whether the property is inherited or not. If you want a full list, you can also go to w3.org where it actually lists down all the different properties that you have and whether or not those properties are inherited. So only if a property is inherited, only then the styles of the parent will be applicable to the styles of the child. And there is one more consideration which you will get to know soon. Confusing enough? If not, just wait for it. It will get more confusing. So let's take case number two. So case number two here is some text in parent. And then as you can see, because some color is a more specific selector, I've given it a color of violet. Violet has applied. And then this text has taken the color of the parent. In this case, it is violet. So violet has come in here. And case three is parent, as usual. So that is the core concept behind cascading and inheritance. So if you look at the slide, you will anyways get this recording, but then take a screenshot of this and stick it on your workspace, wherever it is. So cascading, like I mentioned, it's a process of combining different CSS rules and try to be as specific as possible when writing the selector instead of using the important tag. Now inheritance. So like I mentioned, some CSS property values like color, font are inherited from the parent elements. To get a complete list, go to w3.org. And this is the most important statement. So inheritance applies if no cascaded value is found. So for you to understand this, we have created a handy little flowchart. So let's say you're looking to style an element, for example, color. So have you defined explicitly a color for your element? If yes, we are going to use that color. If you haven't defined a color explicitly for that element, we are going to look at whether it is an inherited property. So not all properties are inherited. So color is one of the properties that is inherited. So if it is a color, then we inherit the value from the parent. If it is not an inherited property, like the border or something like that, then it is set to the initial value. Again, you might get a question, what is the initial value? So as defined in the specifications, the web standards, every component, every element has an initial value. So that is also defined in your MDN documentation under initial value or in this table. So for example, if you see background position, the initial value is 0, 0. So if you don't specify anything, this is the value. Kind of like default value. So that is the logic. It's very important to remember this logic because this is the one that drives what styles are applied to your component. Now it's not over yet. There are two more cases, if you remember, that we have to see. So case three, again, in terms of inheritance, it is your child component. So if you look at it, it's the same child component. It's a yellow background without any padding. And in case three, I've already mentioned before, it is a child of lightning card. But notice in case four, my child component is a child of a div tag. and the div tag has a particular styling, in which case the color is red, and padding is 1 rem. In the previous case of cascading, you have seen that padding does not apply to the child component. But what about color? Now you'll be shocked looking at the output that the color of the text is now red inside your child component, which is inside the shadow DOM. So the initial statement that you know about saying shadow DOM encapsulate all styles is not really true. Now what is the true statement? Is that shadow DOM prevents cascaded styles from affecting your component, but not inherited styles. So padding was a cascaded style, which is why it hasn't applied to your child component. But color is an inherited property. So color is inherited through the shadow DOM. And if you look at the flowchart again with this new understanding, you'll see that cascaded values don't traverse the shadow boundary and inherited values traverse the shadow boundary.
O-
So
Okay,
there
so
is one more property that traverses through shadow boundary, that is CSS Custom Properties, which we'll get into a little bit. But Alba, you were saying
yeah,
something?
yeah, yeah, yeah. So I have a big question here. So
Okay.
SLDS classes, right? So
Okay.
normally I'm able to use SLDS classes to style the inner elements of my Lightning Web Components.
Okay.
But according to what you said, I shouldn't be able, right? Because SLDS classes are basically defining cascaded values for my components. So can you explain that, please?
Okay. Yep, that's a wonderful question. So if almost, I think everyone has already seen that whatever Lightning Web components you create, those are styled using SLDS by default, and you're not importing SLDS into each and every one of your components. So how did we do that? Now, the answer to that again is CSS Scopes. Now, again, a new terminology, but this is really for now, you can consider it to be a workaround because we have to support all older browsers. But we are going to come up with something new in the future. We don't know when that is. But as Alba already mentioned, on the platform, because of backwards compatibility and great browsers like Internet Explorer, we use a synthetic shadow. And synthetic shadow just mimics the standard shadow DOM. It doesn't exactly enforce everything. So how did we mimic shadow DOM's behavior? That is using CSS scopes. So to explain that, let me inspect element on the browser and show you. So any moment now, it should come up. So here it is. So let's take c-child, which is my child component, and then there is a div inside that child component if you remember. But what you notice during runtime is that we have added an additional attribute to this div, to this child, and pretty much to all the elements in your web component have this new attribute. And this attribute sort of indicates what is the name of the component in which it is in. So for example, here it is C child, which means this div belongs to C child. This BR belongs to C cascading parent, obviously because child was embedded inside parent. Now, what is the function of this new attribute that we are adding? Now, this attribute is used to scope your CSS files. So in div child, again, if you remember, I have styled the background to be yellow. But notice in the CSS file, which is this, I've only written div. But during runtime, it has appended this attribute called cchild. And it is the same attribute that has been appended to the tag as well. So using this attribute, we are able to scope all of your styles to your particular component. And if you just click on this style button or whatever that is, if you click that, you'll be taken to the place where all these styles are imported, which is at the page level. So if you can see, this is the HTML root of the page. And inside the head, there are a bunch of CSS styles. And these styles are the ones that belong to your component. So this is because of synthetic shadow. If you were to use native shadow DOM, this wouldn't happen. Your styles would be inside your component. But because we are using synthetic shadow, we've moved your styles outside your component. But to make sure we are still retaining the behavior of shadow DOM, we have added this attribute. And now you may ask, how did SLDS apply to all of my components? So now if I inspect any element, let's say SLDS card is an SLDS style, what you'll notice, it is not scoped, which means it doesn't have any attributes or anything like that. So wherever SLDS card is present in my entire page, this styling applies to that. So that is how we were able to get SLDS to apply to all your components, but the components of your styles remain with your component. And that is the power of CSS scopes. And this is just a slide to help you understand how that is. It's like the attribute that is being used. Now, Alba, do you want to tell us in case of importing additional styles? So, as all of us know, we can import styles from either the static resource or using a shared module. So, how does CSS be affected with imports like that?
Yeah, of course. So there are mainly two ways in which you can import CSS styles in your Lightning Web Components on top of defining the styles in the component CSS file, right? And one of the ways is using a static resource, right? This is indeed the first approach that was available, right? The second approach arrived a bit later after Lightning Web Components were released. And with this approach, using a static resource, what you do is that you create a CSS static resource, you create your styles there in a CSS file that you upload to your org, right? And then you can use a module called Platform Resource Loader to load your styles into your component or into your page, right? The method or the function that we use from this module is load style, and load style returns a promise because it's going to load your styles asynchronously. That means that if you want to import a single file, you can just invoke the promise and that's it, invoke the function and that's it. But if you need to load different styles, you can do things as using the promise.all method so that your styles load synchronously, like not synchronously, but in parallel. So one of the considerations when using load style is that the styles that you load are going to be scoped globally. So we are talking about exactly the same use case that we have in the Lightning Design System. The Lightning Design System styles are not scoped to your components, don't have an attribute that it's scoping them to your components, and it's going to be exactly the same for styles loaded using load style from the platform resource loader module. And I'm going to show you an example of that. Okay, so here I have an example, sorry, this one, in which I created a component that has a button that will call that load styles functions. I'm going to show you the code because you are going to see it very clearly. So here we have our button, and on click, we are going to call this load styles method, which is something that we have defined in our component. And this load styles method, it's going to load some styles from an static resource that I created in my organization. That static resource has some regular CSS, right? And we're going to pay attention, for instance, to this CSS style that we are applying, in which we are setting the font color as orange for spans, right? So let me show you what happens when I click load styles. Yeah. So what
Ooh.
happened here? What happened here? Now my Salesforce org is super nice, right? And what happened is that my styles were loaded globally, same as the lining design system styles on my page. So that means that as we are using synthetic shadow DOM, they are going to apply to all the components in my page, right? So that's okay in some cases, and you can do that, but obviously it's a much more safer approach to load your components in a way in which they are scoped to your component and don't affect the rest of the components on the page, right? And that's something that we can definitely do thanks to CSS modules, right? This is something that was released, I think, 2 releases ago. And CSS modules are simply lining web components in which you just define a CSS file. This CSS file is going to contain the CSS styles that you want to import in your components. It's useful for sharing CSS because you may want to share some CSS that applies to several different components. And the way in which you can import that CSS, those CSS styles in your components, it's in your CSS file of the target component. You write at import and then the namespace and the component name, right? This way, the styles are going to be scoped to the component, and I'm going to show you how. So let's go back to our sample application in which we have another component which is importing the CSS from a module. I'm going to show you the code. It's very simple. So basically, in the CSS file of the component, we are importing the CSS from a module. This is a module that contains exactly the same styles as before, but this time, well, let me refresh the page because I don't like this orange color match, right?
Yeah, our creative team also will not like it if we change it.
Exactly. So this time, what happens is that we are seeing that those styles are being imported correctly and they are being applied to my components, right? But this time, the Lightning Web Components compiler is scoping those styles to our components in the same way that it scopes the CSS styles defined in your CSS file of your component. So it's exactly the same that Aditya saw before, but this time this is going to happen also for the styles that you import using a CSS module, right? So um, let me go back to my presentation. As a summary. So there are two ways in which these styles may affect your components in the page. The first way is global styles, those styles that are not scoped, and that is going to happen with the lining design system styles and also with the styles that you load from a static resource. And remember, this only works when using synthetic shadow, right? In a native shadow DOM, this wouldn't work. And then the second way in which styles can be loaded into your components is in a way in which they are scoped. They only apply to the internals of your component, which is the best practice really, right? And that's going to be true for the styles defined in your component CSS file, and that's going to be true also for CSS styles imported using at import. Great. So we have seen several ways in which we can load CSS styles in your components. Probably you have a question which is the priority, right? Which is the preference? Which styles are going to be applied first to my component? So basically, it's very easy to think about this because basically those that are scoped to your component are going to have more specificity, as Aditya explained at the beginning. So those are the first that are going to be applied, right? And given that we have the same selector with the same specificity, then the order is going to be the one it follows. So first, it's going to take precedence those defined in your CSS file of your component, and second, those imported using @import, right? And next, which are the ones that are going to be applied with less priority? Those that are global, because those have less specificity. So basically, those imported with load style or the lining design system. Right.
So wow, that was a lot. I think now at least we would have confused you. That is our intention. We want all of you to go back, do your research, do a lot of trial and error, and really learn how styles are applied, because you spend that effort now and then you don't have to spend it during debugging. Now, moving on to an important concept, which is the second type of properties that I said pass through Shadow DOM. Those are CSS custom properties. And Albert, do you want to tell us what is the real use of CSS custom properties? When do I use them in my components, and what advantages do I get?
Exactly. So CSS Custom Properties is another CSS topic, another CSS feature, sorry, that we can use not only in Lightning Web Components, but in any web application, right? And these are also known as CSS variables, right? Maybe you have heard about them somewhere. So CSS Custom Properties are going to allow you to basically define a value for a CSS property that you want to use somewhere else, probably reuse it in several different places, and then you can use that value referencing the parameter with which you define it. So better to see that with our example. Let's say that I want to define a subtitle color, whatever name you want to use here, that is black, right? So what you can do is to define a CSS variable or custom property that says that my subtitle color parameter is going to have a value of black. And then in a later moment, you can use the CSS property using var and then the name of the CSS property that you defined. So this is going to evaluate to black. Can you use it anywhere in your page? No, you can use it right under the scope in which you defined the value for that property. I mean, if this property was defined in an element or a hierarchy in your DOM in which a span is not part, from which a span is not part, then here we are not going to be available to see the value of that property, right? You have to define it in a branch of the DOM in which a span is a child of. What's the issue or the benefit that we can get from using custom properties in regards to Shadow DOM? That they are able to traverse the Shadow DOM. So if sometimes you need to apply a cascaded value to an internal element of Lightning Web component and you are not able to do that because of Shadow DOM, you can use CSS properties to try to overcome that restriction, right? And there are many places in which we are using custom properties as styling hooks, aura design tokens, and lining design system tokens that Aditya is going to explain in a second. But first, I want to show you some examples of CSS custom properties in action. So if we go back to our page, right, we have another example here in which we have several components for which we are using custom properties to traverse the shadow DOM and apply some colors to these elements here. And we are going to see that in the code. So let me open. We have this element here, which is the custom properties container, is the parent component, right? And in the parent component, In the parent component, we are defining, well, basically a subtitle, and then we are using a child component. We are instantiating that child component 3 times because we want to demonstrate how custom properties work and how you can define different custom properties for different scopes. So if we take a look at the CSS file, we see here that first we are defining a custom property. This is, we are defining a value of a CSS property that we want to reuse later in one or different places. We are defining that at host level. When we use this host selector, it means that whatever we specify here is going to apply to the whole component. We are referring to that shadow host element that we mentioned at the beginning of the talk. And then we are using that property, for instance, to style the subtitle, right? The subtitle class, the element that has the subtitle class. As that color is green and my subtitle class is being used here, that's why we are seeing this element styled with green color, right? But the same works when using web components, when trying to traverse the shadow DOM for web components. If we take a look at the implementation of these HTML, the HTML file of the web component, we see here that we have a simple paragraph with a span, right? Pay attention to this span. And in the span, we are using the value of that property. We are using the value of that custom property to define the color. That means that as I'm defining the color, the property on the parent, sorry, not this one here, is this one here? Yeah. As I'm defining the property on the parent, right, I'm going to be able to use the value same as I'm using here in the subtitle. I'm able to use it within a Lightning Web component that is a child of that component. They are able to traverse Shadow DOM. So what's going to happen? That on one hand, if I just use, so if I take a look at the component that is a direct child of the host and for which I'm not specifying a class, its color should be green, which is the one that I'm setting for the host. But what I can do is to even override the value of that property with a selector that has more specificity. So for instance, I may say that I want it to be red for the class color 1 and I want it to be blue for the class color 2, right? And that's why when I take a look at my 3 components on the page, we're going to see that the first one is green because it's taking the value of the property that was defined at host level. And the next ones are taking the value of the properties that were defined for the first class, color 1, and the second class, color blue. So this is a technique that you can use, and it's something that, again, we use internally. This is something that needs to be allowed explicitly in Lightning Web Components OSS, right? I implemented the same example for Lightning Web Components OSS, this one here. And if you take a look at the code, this is something that we need to specify in our LWC services configuration, but it's definitely something that you can use. And with that, I'm going to let Aditya continue talking about the different usages that we do of custom properties on the platform, on different platform features.
Cool. You're showing my screen?
Yeah.
Okay. So all of you have seen custom properties in action. And one example that I mean, custom properties are used literally everywhere in Salesforce. So if you inspect element and scroll down to the bottom on the right hand side, you can see like hundreds and hundreds of custom properties. And one classic example I can give you is the density settings. So you've defined maybe in your own components SLDS cards with some padding. And the moment you change the density on the org level, all of the components reflect the new padding. So if the density is compact, the padding is reduced. If it's comfy, the padding is increased. So the way we've done that is using custom properties. So all of your base components, they use custom properties, and we just change the value of the property at the root level of the HTML, and then it applies to the whole org. And what you would have also noticed is in this example of custom properties, we told you that you can define the custom property value at the parent level and you can use that value in the child. And whatever value you define in the parent, the child is going to reflect that value. So that is custom properties. But if you look at it in a different way, let's say you are the one who built the child component. So what you're doing is you're defining your styles in such a way that they can be customized by the parent. So the person who developed Astro and Cody are good friends component, they have developed it in such a way that a parent can control the color of good friends. So that is how you can also look at CSS custom properties. And that is exactly how styling hooks have been built. So these lighting based components are something that we have built as Salesforce. But we want to allow you as developers and customers to control various behaviors of this base component in terms of styling. So for that, instead of like hard coding the styles, so in our lighting button, we could have put background color is blue. We could have hard coded it. But instead of hard coding it, we have used custom properties. So what we have said is in our own component, we've said background color is this property. So what that allows you as a developer to do is in your components, you can define the value of this property to whatever it is that you want, and the base components would reflect it accordingly. So here is an example. Okay, so I have two buttons. One is shown in orange, one is shown in black. Now, if I look at the code behind that, so let me go to stylinghooks.html and then stylinghooks.css. So you can see it's a simple lightning button. I have put it inside a div and lightning card. And here I've defined another div with class of color1, and I've put the lightning button here. Very similar to what you have seen in the previous example with custom properties. So there was a parent component and then the child component is placed inside different divs. Only in this case, instead of your own custom component, it's a base lightning component. So as you would assume, if I wanted to change the color, I just need to identify what is the property name. So as a developer, I have to give it to you in documentation saying that, okay, if you want to override the background color, this is the name of the property, SDS button, whatever it is. And then you mention it is orange at the host level, which means all the buttons are orange. But if you want to override it at a div level, so only the lightning buttons inside this div have to be in a different color. Then you just define the class name and then override the value of the custom property here. So here it have given it as orange and black, and that is exactly the output that I got. Now, how do you know what is the name of that custom property that you're supposed to use? Very simple. Go to the SLDS website. Let's say I want to customize the appearance of this button. You scroll down all the way to the bottom, and you have a section called Styling Hooks Overview. And here it's going to give you all the different custom property names that you can use to override various aspects of that button. So not just the background color, but border color, what is the color that comes on hover. There are so many properties that you can explore. And we are rolling this out. This feature is currently in beta. And as a best practice, because now we have rolled out styling hooks, please do not overwrite the styles of components this way. So even though you know Lightning button uses SLDS button brand as a class, don't try to overwrite the color, because this way you don't keep up with the updates that we are making. What if we change the internal structure of the base component? This class will not apply anymore. And also coming to the concept of specificity we discussed earlier. What if we make sure the styles that we have defined are more specific than what you have defined? The style won't apply. So you
Yeah,
don't
and
use
and
override. Yeah.
and imagine what happens when we move to native Shadow DOM, right? Because
Oh yeah.
SLDS styles are simply working because we are using the synthetic implementation.
Correct. So be careful, which is why we are doing this session to tell you what you can use and what you cannot use so that your components are future proof. So use styling hooks as much as possible, and we are always looking for feedback, as you know. We have rolled out styling hooks for quite a few components now, but in case you have a component for which you don't find any styling hooks, let us know. And if more number of you request for the same component, we are going to prioritize that. It's as simple as that. We are looking at you to decide what components that you want styling hooks for. And exciting news, global styling hooks are coming soon. So in the example I've shown you are defining styling hook at the component level. But what if you want to override the styles of lightning experience? So here you're saying the lightning button in your component is black. But what if your customer has a theme where, let's say, the standard save button also has to be black? How do you do that? Right now, you can't. But with global styling hooks coming in the future, you will be able to do that. Again, forward looking. Whenever it comes, we will let you know and we'll do a session on that. So that was about styling hooks. Now, next, Aura design tokens. You should already be knowing about it because Aura was there for like 6 years now. Um, so the very same concept of CSS custom properties is Aura design tokens, where custom properties is more a web standard, but Aura design tokens is what we created as Salesforce to make up for that web standard. So with tokens, what you do is you define just like a property, the name and whatever its value is, and you use that in your Aura component CSS file, like you say token, and you give the token name. But because we are all for web standards and we want you to use your Aura design tokens everywhere, in Lightning Web Components, you can use your Aura tokens as well. How? Using the custom property syntax. So there is a specific syntax for this. So here it is hyphen hyphen C, which is the namespace, and hyphen name of the token. So that way you can create an Aura token and use it across both Aura and Lightning Web Components. Something that you might want to consider for reusability purposes. And finally, SLDS also has design tokens. So in case you want to use the styles defined by SLDS, for example, the label color, it's not black, it's slightly grayish. And you don't want to, in your components that you create, and in case you want to style it using the same way, we don't want you to figure out what the color is and then hard code this value. You can directly use the token from SLDS to style your components the way SLDS looks. Only thing to remember is the support has to be GA. So there are some design tokens SLDS uses, but for internal purposes only, which you cannot use in your Lightning Web Components. Whatever is GA, you can use those. The syntax is hyphen hyphen LWC hyphen whatever is the token name. So this way, CSS custom properties allows you to maintain configurability across your entire custom component suite. So that when you drag and drop your component onto the app builder, you give a lot of control to the admin. So in case they change the density, it's going to apply. And if another developer wants to embed your component and style it according to the way their org looks, they can use CSS custom properties and so on. So try to use this also as much as possible, mostly whenever you're creating reusable components. So that was design tokens. And one important discovery I've made in the recent times is that you can even use your JavaScript property values in your CSS file. So let's take this example. So I have built a reusable component, let's say, and I have a div and a text inside it. Right now, the background is black and text color is white. But I want the admin to configure this. So I want the admin to say, I want the background to be red. And from the app builder, so this is that component, I can select that and it shows the properties that I've exposed to the app builder. Nothing new, it's already possible, you know that. So I just changed the color to red and you see the background color has changed to red. So how did I do this? I mean, you can do this using pure JavaScript, of course, but as we have repeatedly said multiple times in all of our sessions, manipulating DOM using JavaScript is not recommended. So what we have done for that, we have again used custom properties. So the way we have defined it is in the CSS file, we have defined two custom properties. We called it black and white, and that is what we are using to define the background and color. So background is my BG color and color is my font color. So what am I doing in my JavaScript file? Whatever is the property that is set by the app builder admin, I'm actually setting it as a property value. So I'm just querying the container or the host or whatever it is that you want, where you define the property. And I say dot style dot set property, and I define the property name, and I use the JavaScript value. So that way, whatever value is there in JavaScript, it is being assigned as a CSS property value. Now you may ask, why do I do all of this? Why can't I just set this value to my element? Again, reusability. Let's say you have 10 elements. Will you write 10 statements to set the same color to all the 10 elements? No, right? So you just need to set the property once and all of the classes for all the 10 elements can use the same property value. So that is one more advantage of CSS custom properties. So the more you embrace it, the more benefits of it you will get to know. And with that, we are at the end of our session. Hopefully by this time you would have pulled out your hair. If not, we are happy that you've understood most of it. But if you have pulled out your hair, please rewind and watch the same session at 0.25x speed. And we'll be grateful if you can give us feedback. So to summarize, Albert, you want to summarize or should I?
Okay. So, well, we have seen today what Shadow DOM is, the different implementations of Shadow DOM that we have in Lightning Web Components, and how important is to understand that, because that is going to be the key to understanding how CSS cascading and CSS inheritance is going to apply to your components, but also how Lightning Design System global styles and styles loaded with load style from the platform resource loader module are going to be globally scoped to your page, in contrast to those CSS styles that you define in your component file or that you import using a CSS module. It is important, as you have seen, to master CSS, to have a good understanding of how CSS works, on top of understanding how Shadow DOM works. So make sure to invest some time taking a look at all the concepts that we explained today. And finally, we have seen how CSS custom properties can be used to traverse Shadow DOM, and it's a feature that we use widely through several features that we have defined in Lightning Web Components, as for instance, styling hooks or design tokens in Aura and the Lightning Design System. So, if you liked the examples that we used today, we have them in a GitHub repo. We're really in two GitHub repos which are public. You can navigate to those repos and clone them and play with the examples. Take a look at the different branches that we have on the repos, because we have iterated on this talk several times and we have different implementations in different branches. And if you have any questions, of course, you can ask them to us. And finally, I wanted to tell you the different social channels in which you can connect with us. Remember that we have our developer site in which we publish very frequently blog posts, the developer podcast, and we have all the developer documentation available. You can also connect with us on Salesforce Dev's Twitter handle on Twitter, but also on Alba SFDC and Aditya Nag, and we will be very happy to connect with you and respond to any questions that you have. And we are also in other channels as Facebook, LinkedIn, and YouTube. Probably you are watching this on YouTube, so if you like the video, make sure to like it, make sure to
Subscribe
subscribe. Yeah.
and hit the bell icon.
Exactly. Make sure to subscribe to the channel and to click on the bell to receive notifications, and comment in the video. Let us know what you think. Ask us anything there, and we will also monitoring the different videos on the sorry, the different comments on the video to make sure that we respond to everything. So thank you so much. It was super great to present this with Aditya. Aditya, hope that you enjoy the experience. Is our
Yeah,
first webinar together.
it was good, and it's on YouTube, the first webinar. So it's nice. I had a great time presenting with you. I hope all of you had a great time listening to us. And like Alba mentioned, please leave your feedback on comments, questions, anything. We are open to receiving anything, basically.